For today's lesson, we're going to be discussing transformation geometry. Within this exercise, we're going to discuss a translation, axial symmetry, and central symmetry, involving this arrow shape, the yellow arrow. So the first thing I'm going to say is the translation is going to take place in a downwards fashion. It's going to end up in this area. Axial symmetry will head across horizontally and end up in this area of the board. And finally, central symmetry will end up in this area of the board. The first thing we must do on our object is label it. So I'm going to label the arrow here, and I'm going to label it A. For our translation, we must get our set square or our t-square and bring down our points. So we're going to bring down point A 120 millimeters. So 120. And we're going to label now A1. A now becomes A1. The second thing on our object we do is bring down the other points of the shape. Like so. We bring this down the same distance and in the same direction as point A was brought down. So this is how our shape will translate. It will basically come down as far as point A, and that is our translation. The next part of the transformation geometry exercise is axial symmetry. For axial symmetry, we need a line of symmetry. So the line of symmetry, since our object will end up over here, our line of symmetry will be in the middle. Like so. And we're going to label that X, Y. So our line of symmetry is now X, Y. So all our shape and our points go through the line of symmetry. So point A1 goes through. We're going to measure from point A1 to the line of symmetry, which is here, which is 40 millimeters. We now, for axial symmetry, the distance from here to here and here to here to get the next point must be also 40 millimeters. So there's our new point. You can also do this using your compass by putting your compass here, marking here and swinging over and marking it in. It's the exact same way as using your set square, your t-square or a ruler. So A1 now becomes A2. And now from our yellow arrow, we bring across through our line all of our points. As you can see, the line of symmetry needs to be extended a little bit. And again, we must measure from here to here to get our point over here. And we measure from this tip of our arrow in and again over. As I've already said, you can use your compass to mark from here to here, swing it and swing across, and so on for the other part. So now I'll show how our arrow ends up when we go through our line of symmetry. So basically when our points are going through, our shape flips as this acts as a mirror or a line of reflection. And now it's facing back towards it. So basically our line of symmetry acts as a mirror or line of reflection where all our points go and our shape flips, as you can see. Finally, we're going to do central symmetry. As I said previously, it's going to end up in this area of our whiteboard. So A2, we must get A3. So we bring this up. As we've already said before, 120 millimeters. A2 to A3. Here is our A3, 120 millimeters. To get the center of that, we divide it by 2. So half of 120 is 60 millimeters. The key part here for central symmetry, we must label this point. So I'm going to label it letter B. And that's the most important part of central symmetry. The next important part is that all our points, since A2 has went through B and now to A3, we must bring this point of our arrow through and the other point of our arrow through point B. That's the most important part of central symmetry. All points of our arrow go through point B and end up here. So when all points go through and A2 has went down and became A3, our shape now becomes in a new position on our page. As you can see, everything goes through B, and that is the difference between axial symmetry and central symmetry. So to recap, a translation is basically moving our shape or our object, in this case the arrow, in the same direction, the same distance. Here we see that it's moved downwards, became A1. For central symmetry, we need a line of symmetry. As you can see, we have a line XY here. So the distance of this shape must be go through the line of symmetry over to here. So as you can see, I measured this with my T-square. Some people can use their compass or their set squares to measure from the point A1 in to where the line hits the line of symmetry. Here we see it's 40 millimeters. Then again, it must be 40 over here, so we can mark with our compass, our line, our tri-square. We do the same for the other lines. We bring them across horizontally and measure them, like so. Swing it over if you're using your compass, or else use your set square, measure and measure it in. Then A1 becomes A2. Our shape flips as it goes through the line of symmetry, and now you can see our arrow is facing back at our other arrow. Finally, for central symmetry, the difference between that and axial is that we need a center point. So all these points from our arrow, A2, must go through the point B to become A3. And the other points here and here, which you can see go through B, end up here. As you can see, our shape has flipped back again in a different direction, but it's also moved back. But A3 is still in the same position as A2, and it's in line as it's going through point B. So that's a basic recap of a translation, axial symmetry and central symmetry of transformation geometry.